I share screen. Is it visible?
Yes, sir.
Okay. So if you remember in the last lecture, we discussed about how to draw a cam profile when the follower motion is simple harmonic motion. And for that simple harmonic motion, the follower given was Nypage follower, which is radial follower, and the cam rotating clockwise. So we discuss first numerical. Now in this numerical, we'll try to discuss second part of the numerical. So I just briefly revise what we discussed in last through this video. Okay. See, so first step in drawing is to draw a displacement diagram, and I hope you remember how to draw displacement diagram. In displacement diagram, you have to draw two axes. One is x-axis, other is y-axis. So here on y-axis, here we have to draw a follower displacement, which is given in the numerical. As the motion is simple harmonic motion, we have to draw a semicircle of diameter is equal to stroke of the follower. Then divide this semicircle into n number of parts. Now, how many parts we take? It depends upon in how many parts we are going to divide the cam displacement on x-axis. Here I take 6 parts. So let's say we call it as different names are given 1, 2, 3, 4, 5, 6, 7. For rise 1, 2, 3, 4, 5, 6, and for dwell again it will be 7 to 12. So let's divide the semicircle into 6 parts. As total angle is 180, we divide each angle or each division is 180 divided by 6. How much it will be? 30 degree. So divide into each division is equal to 30 degree. Divide this into 6 parts. Next, we have to divide this cam displacement during rise or during return into same parts. Here I divide into 6 parts. So you can also divide cam displacement into 6 parts. Depends upon scale. So angle suppose 120 degree, then take suitable scale and divide that 120 degree into 6 parts. So divide x-axis also into 6 parts. This is just revision of last lecture. I'm saying what we discussed in the last. Then project these points. Let's say this 1, 2. The names are taken here now. 9 to some names are different, but okay, we can project the points on a vertical projections through that x-axis. So we can take these projections. Now join this. Actually, these projections are shown here. How we are taking projections up to where? And join them by smooth curve. This is what how to draw a displacement diagram for a simple harmonic motion. Now next, we have to draw a cam circle of base circle radius is equal of the circle radius is equal to base circle radius. Next, divide this cam angle into same parts. So here 6 parts are there. So divide your cam angle, that is theta O, again into 6 parts. And after dividing that points, join these points with center. Remember, whenever it is Nypage follower, you have to join with center. So here it is dividing into 6 parts. We can divide by taking angle also. Here they take arc to divide, but we can divide by angle directly. We don't draw it, just I'm revising the last lecture. And join with center. Now one more thing, remember, here we divide into 6 parts. And remember why we are dividing into anti-clockwise manner? Means we started from this point to this point. Why anti-clockwise? Our assumption is the cam rotate clockwise. Second thing, suppose this angle is 90 degree and we have to divide into 6 parts. So each division is equal to 15 degree. So you can take directly angle and then divide, or you can take 15 degree angle separately and then you can mark arc like this. So different ways to divide the circle that might known to you. And if it is Nypage follower, divide that point on a circle, that is division, with join with center. Join that point with a center if it is Nypage follower. So for a Nypage follower, we have to join each division with center of the cam, and then join these lines, extend these lines like this. So as it is 9 page follower, I join the divisions with centers. After marking these lines, we have to transfer this distance. Let's say this distance of first 1A, let's say, then 2B, and so on. We have to transfer this distance that already we discussed in the last case. So this distance, you can see the arc, compass. Okay. Transfer corresponding distances on the line joining with center. You can see likewise we can transfer distances and the last distance for the outstroke. After this, join these points by smooth curve. So that is your cam profile for a simple harmonic motion during rise. I think this we discussed. Is it clear? Hello?
Yes, sir.
Okay. So that was our last part. Uh, just wait, I'm sharing screen. Okay, is it visible now? Hello?
Yes, sir.
Okay. Okay, is it visible? Hello, hello.
Yes, sir.
Okay. See, in the last lecture, what we discussed, I just discussed with you in detail now. So this is second problem we have to discuss. You can go through this numerical. Likewise, a numerical is given to you. See what is given. Design a cam for operating the exhaust valve of oil engine, which is required to give uniform velocity. So what you have to design is you have to design a cam, and for what it is used? It is used to operate the exhaust valve of oil engine. Now, what is given about in detail about motion, which is required to give uniform velocity during opening and closing of the valve. So, what do you understand from this sentence? Yes. I repeat, which type of forward motion is given? See, I am again repeating, design a cam for operating exhaust valve of an oil engine, which is required to give uniform velocity during opening and closing of the valve. So, which type of forward motion is given?
Uniform velocity.
Uniform velocity. But is it that uniform velocity is during rise, and what about return stroke then? Or during both it is uniform velocity? Yes. See, it is given during opening and closing of the valve. Means opening and closing means when it open it rises, and when it closes it will
Yes.
retards. So during both strokes, means opening and closing, it is a uniform velocity. So for rise as well as return, the motion of the follower is uniform velocity. So in your given data, we can write theta O is equal to something, and the motion is uniform velocity. Theta R, some angle will be given in next sentences, and again the motion is uniform velocity. So in this problem, both strokes, that is rise as well as return, we can say outstroke as well as return stroke, both occurs with a uniform velocity. Is it clear? Motion is clear? Please reply.
Yes, sir.
Okay. Now see second thing, outstroke corresponding to 120 degree of cam rotation. So what do you understand by this? Outstroke means rise of the follower. Outstroke corresponding to 120 degree of cam rotation. So theta O is equal to 120 degree. I request you, you can write this data. Theta O is equal to 120 degree. In bracket, you can write uniform velocity, uniform motion. So theta O is given. What is given next? The valve must remain in fully open position for next 30 degree of cam rotation. Means what?
Dual angle.
See, it is given first it rises during how much degree of cam? When cam rotates through 120 degree, follower will rise from 0 to 120 degree. Follower will rise. Then for next 130 degree, follower must remain fully open. Fully open means it is not moving. So it is stationary. So during this time period, the follower will not open. Follower will not move. So it is stationary, and hence the angle is dual angle. So theta D is equal to 30 degree. You can see the sequence also. Theta O is 120 degree, theta D is 30 degree, and next given a return stroke corresponding to 60 degree of cam rotation. So what you understand by this? Theta R is equal to 60 degree. I think it is clear what the sequence is, how the rise is there, how dwell and how return is given. I hope angles are clear and motion is clear.
Yes, sir.
So try to read the numericals like this. From this data, we have to write down in short. Okay, brief data we have to write. And next sentence. The lift or stroke of the cam is 30 mm. Why this lift is required? Tell me. Where it is required? Lift or stroke of the cam is 30 mm. Where it is required? To draw displacement diagram. On y-axis, we have to draw the stroke or lift of the follower. So it is 30 mm. So remember, lift or stroke is required to draw a displacement diagram y-axis. And next one, the minimum radius of the cam is 50 mm. Where it is required? Remember,
Base
minimum
circle.
radius of the cam is nothing but base circle radius, RB. Okay, and with this radius, you have to draw a circle. The first circle we are drawing, that circle will be of this radius. Minimum radius of the cam is 50 mm. So this radius is required to draw a cam circle. Okay, then the follower is provided with a roller radius of 10 mm, and its line of stroke passes through axis of the cam. So what you understand my last sentence? Which type of follower it
It
is?
is
Roller
radial.
follower.
Radial.
First thing it is clear, it is radial follower because line of stroke passes through axis of the cam. But I want to ask you, which type of follower it is?
Roller follower.
Okay. Okay. So this is about numerical given. Now I request everyone to write given data. Take some time and write down given data from this numerical. If any doubt, you can ask me. मी त्यांच्यासाठी लेक्चर घेतच नाही, ज्यांना काही गरज नाहीये. Those want to learn something, for them I am taking lecture. So take time and write on this. If you understand, then it is good. Completed? Write down given data. Okay, I hope you completed that. Now see next, how to write this given data. So this data is given to you, can see theta O 120 degree, then theta R 60 degree, theta 12 30 degree. Lift of the follower is 30 mm means 3 centimeter. Minimum radius of the cam is 50 mm, that is 5 centimeter. Roller radius is given, which is 10 mm. Now see, up to this, when it is knife edge follower or it is flat face or any other follower, only one circle radius is required. That is minimum radius of the cam is required. But whenever it is roller follower, then we need to consider one more radius called as a prime circle radius. And that prime circle radius is equal to minimum radius of the cam plus roller radius. And hence, whenever it is problem on roller follower, so which type of follower it is given in the case? In this case, roller follower. Remember, this numerical is basically I am trying to cover topic how to draw cam profile when the follower is roller follower. So focused on that concept. So what is required to draw roller follower? Basically, in addition to the knife edge follower, here we required prime circle radius of the roller, and that prime circle radius is equal to minimum radius of the cam, which is also given in case of a knife edge follower, plus roller radius. So it is 50 mm plus 10 mm, it is equal to 60 mm. That is prime circle radius is equal to 6 centimeters. So here in case of roller follower, we have to draw two circles. That is, first one is a circle with minimum radius of the cam is equal to 5 centimeter, and another circle with prime circle radius is equal to 6 centimeter. But as usual, the first step is not to draw cam profile, but first step is to draw displacement diagram. And for displacement diagram, what we require is to draw displacement diagram, you have to select suitable scale. So what scale you will prefer for y-axis? Yes. On a y-axis, we have to take 3 centimeter. So can we draw 3 centimeter on y-axis? Yes, it is feasible. So whenever it is feasible, that is 3 centimeter only. So we can take suitable scale. Remember, it is not essential that you have to take same scale. What I'm saying, you can take as you wish. Okay, I prefer 1 centimeter is equal to 1 centimeter on y-axis, and on x-axis we can take suitable scale. See, both motions are with uniform velocity, means rise also and return also. Outstroke means rise, and theta r is written here. So on y-axis also, sorry, on x-axis also we have to take suitable scale. Let's say we take theta o, or for x-axis we take scale 20 degrees equal to 1 centimeter. Means on x-axis, how much centimeter I have to draw for drawing outstroke? Yes.
6 centimeter.
Yes. And for return stroke?
3 centimeter.
For dwell? Scale is 20 degree. 20 degree is equal to 1 centimeter. So we divide by 20.
1.5.
3 by 2. Okay, likewise. So first step after writing given data is to draw or to select suitable scale and draw displacement diagram. So you can see now scale considered here. So for x-axis they consider 1 centimeter is equal to 20 degree. On y-axis we consider 1 centimeter is equal to 10 mm. 10 mm is 1 centimeter only. Don't get confused. Okay. And after this you can see we convert this theta O 120 degree. Here it is given as a 6 centimeter as a scale. Then for dwell it is 1.5 centimeter. As the angle is 30 degree and scale is 20 degree. Then for return it is 60 degree angle. Scale is 20 degree. So 60 divided by 20 it is 3 centimeter. So 6, 1.5 and 3 centimeter is the scale considered. Now after this we have to draw displacement diagram. Now anyone tell me procedure to draw displacement diagram? Yes. Basic procedure. What you have to draw in displacement diagram? You have to draw x-axis, you have to draw y-axis, you can draw rectangle also of height is equal to, yes, height of displacement diagram is equal to
3 centimeter.
Yes, good. 3 centimeter as displacement of followed is 3. All of you written given data? Second data लिहून घेतलाय का?
Yes.
Okay. So height of the displacement curve is equal to 3 centimeter. And for x-axis, we have to draw theta O, theta D, and theta R. Be careful about sequence given. In some numericals, it is not always outstroke, dwell, and then return. It may be dwell, return, and then dwell. Sorry, it may be rise, return, and then dwell. So be careful about what is given in the numerical. In this numerical, the sequence is rise, that is outstroke, dwell, and then return. So follow the sequence which is given in the numerical. So for drawing displacement diagram, you have to consider x-axis. And you can see here, what we mark here is on x-axis first we mark 6 centimeter. Why 6 centimeter first? You can check this. Why 6 centimeter first?
Outstroke.
How much outstroke angle is?
Outstroke is 6 centimeter. 120 degree.
120.
120 degree. And our scale is 120 degree is equal to, sorry, our scale is 1 centimeter is equal to 20 degree. So 120 divided by 20, that is 6 centimeter. Therefore, we consider 6 centimeter as a first part. Second part, 1.5 centimeter. Why 1.5? Because dwell is equal to 30 degree. And the last one, 3 centimeter, because return is 60 degree. So likewise, we can consider 6 centimeter theta O, 1.5 theta D, and theta R as 3 centimeter. On y-axis, we consider 3 centimeter. This is the end of the return stroke, rise stroke, end of the dwell, and end of the return stroke. Now, how to draw for uniform velocity? Which motion is given here? Uniform motion. It is the simplest method when the motion is uniform motion. As usual, we have to divide into 6 parts. So, as it is 6 centimeter, you can see here, as theta O is 6 centimeter, we make 6 parts. And one part is equal to 1 centimeter. So try to take equal parts, easier parts. That's why we take a scale is equal to 20 degree. So if I take 20 degree, each part is equal to 1 centimeter. So divide into 6 parts. Now what about return stroke again? You can see here also we take how many parts? 6 parts. 1, 2, 3, 4, 5, 6. Now you know how to divide into 6 parts. This is lift of the follower. Theta O, theta D, and theta R. Now, if it is uniform motion, it's very easy to draw displacement diagram. Nothing to do, just join diagonals. So, join this diagonal with this diagonal. It is your displacement curve directly. The points on this line gives you the corresponding height of the follower. So, initially it is 0. It may be some height at the next point, next height, next. This points gives you height. So, this just when it is uniform motion, no need to draw any other thing, just divide into 6 parts and join both diagonals. Similarly, here also we can join both diagonals so that you will get displacement curve. You can see this. This is your displacement curve. Okay, this is displacement curve for rise stroke, dual stroke, and then it will be a return stroke. After this, we have to consider the points on this. So you see here, this is your complete displacement diagram. Theta O, 6 parts, theta R, 6 parts. A, B, C, D, E, F are the corresponding follower displacements during rise stroke from O to F or 0 to F. Then from F to H, we can say H, I, J, K, L, we can say. These are the different points representing follower displacement during return stroke. I think you get how to draw displacement diagram when the motion is uniform motion. In the last lecture, we discussed simple harmonic motion. Today, we are discussing displacement for a uniform motion. Very simple. Divide into equal parts, 6 parts, 6 parts. Join the diagonals and mark corresponding points on the projections, vertical projections, that is A, B, C, D, E, F, F to L. This is your displacement diagram for a uniform motion. Any doubt about this? About displacement diagram? If no doubt, you can draw it. Draw displacement diagram. Yes, completed. Once you complete, then tell me please. Draw displacement diagram. Very simple. When uniform motion, it's very simple. Just draw diagonals. Join diagonals by straight line and mark corresponding points on positions. If any doubt, you can ask me. Can I go further? Can I start next topic? That is
Yes,
cam
sir.
profile. Cam profile. Okay. So this is your displacement diagram. Now we have to draw a cam profile when the follower is roller follower, and the follower given is knife edge follower. Sorry, radial follower. Radial roller follower. Remember, in case of a knife edge, in case of a flat face, in case of a oscillating follower, only base circle radius is required. That is minimum radius of cam is required. But to draw a cam profile with roller follower, 2 circles are required. That is base circle and a prime circle. So here we need to draw a radius of, you need to find out radius of prime circle in the given data only. Already we find out it. If you remember, the radius of the base circle is how much? Given how much it is? Base circle radius means minimum radius of the cam. How much it is?
50 mm.
5 centimeter.
5 centimeter.
5,
And then how much we got prime circle radius?
6 centimeter.
6,
6
6
centimeter.
centimeter. Because in that case, roller radius will be 10 mm. Is it right? Because prime
Yes.
circle radius is equal to radius of the roller plus base circle radius. So I know now both radius. So we can draw now cam follower, cam profile for a roller follower. First step, draw base. Okay, we'll explain now with this animation. Okay, already discussed this. Okay. So here see now, we have to draw 2 circles. This inner one is how much radius of this one? This circle is? Yes, we drawn 2 circles
5.
basically. Yes, this one is 5 centimeter circle, and other is 6 centimeter circle. You can see here, roller circle is drawn, and that roller radius is equal to 10 mm. Okay. Now, if it is knife edge follower, just you have to join the cam center with prime circle center. And if it is knife edge, means you have to draw a vertical line through this cam center, perpendicular to cam center. Join this first point. This is your first position of the follower. Remember, whenever it is radial follower, follower axis passes through cam center. So your first point is draw a line, vertical line passing through cam center. And in case of roller follower, trace point is at prime circle. In other followers, trace point is at base circle. So consider this is your first position. I think this arrow is visible to you. I'm showing this is your first position. And now, after this, in this case, it is not given whether it is given whether follow cam rotates clockwise or anti-clockwise. Yes, is it given cam rotates clockwise or anti-clockwise? I think not given. If not given, we assume it is rotating clockwise. And if cam rotates clockwise, then we have to divide this theta O, theta D, theta R in anti-clockwise manner. So here we are assuming that cam rotates clockwise, and hence we consider it as anti-clockwise. Means divide will be anti-clockwise. We will divide in anti-clockwise way. So first angle is theta O. How much it is? 120. So mark 120-degree angle in anti-clockwise way and divide into 6 parts. Then mark 30-degree angle. No need to divide as it is 12 period. Then mark 60-degree angle and divide into 12 parts. So you can now see how we are going to mark the angles and how we divide it into number of parts same as displacement diagram. It is very important. Number of divisions we take on cam profile, cam circle is same as displacement diagram divisions. You observe it now. So this one is prime circle and base circle. Roller radius is drawn already. We have to divide. You see how the divisions are made? Up to 120, you can see up to 120. This is your theta O. Then this is theta D. No need to divide. And the remaining is again 60-degree. So from here again 60-degree you have to consider. And how many parts? 6 parts. This is 120. So this one is 120-degree. This one is 30, and this one is 60-degree. So now on this, you can see here, important one. We divide this circle into parts equal to these angles, that is 120, 30, and 60, and join the divisions with center. Why I join with center only? Why I join this division line with center? Or when to join with center? I already told you. Yes, anyone? When to join with center?
Uniform.
No. I'm asking about the cam
Same
profile.
motion. When there is the same motion.
See, actually, remember when it is radial follower, then join these lines with center. When it is radial follower, then join with center. Keep in mind. Means what we are doing, we are marking theta O 120-degree, and this is more clear when you consider numerical or an offset follower.
Sir, you are not audible.
Sorry, actually I explained a lot of things when my mic was off. Okay, which last point I told you? Actually, I explained a
Why
lot of
we
things.
choose from line? Why we join lines to center?
Okay, that is clear to you. When we join line with center,
Radial
see,
follower.
When it is
yes.
radial.
Now remember, when our follower is radial follower, we have to join the divisions with center. And why it is? Because we observe here in the first position. Actually, in case of radial follower, follower axis passes through center. When you call follower as radial follower, when its follower axis passes through center of the cam. So this is your first position. The roller forward is shown here, and its axis passes through center. You know that. But we assume while drawing cam profile, the cam is stationary and follower is rotated in opposite direction of cam rotation. This is our assumption. I repeat, what is our assumption? It may ask in oral or in online also. That is called a principle of kinematic inversion. In drawing cam profile, what we assume is cam is stationary and follower is rotated around the cam. So follower initially here, arrow is visible. This arrow is visible. I'm showing here.
Yes,
Yes.
sir.
Yes,
Okay.
sir.
This is initial position. And what we assume, I will rotate this follower in opposite direction around the cam. But opposite direction of what? Cam rotation. Assuming cam rotation is clockwise. So we rotate this follower in anti-locus direction. And that's why we divide in this anti-locus direction. Now, at each point, let's say this is second position. So here follower is, roller center is here at this point on a prime circle. I hope you got difference between prime and base circle. The inner one is base circle, outer one is prime circle. So roller center is at prime circle. So I have to join in each case that follower axis must pass through center. And hence I join that these lines with center as the follower is radial follower. So it will be, these lines indicate direction of follower axis or direction of follower motion. Is it clear? Now my question to you is, I have to mark this point, that is 0 to 6 and 6 to 12. Where should I mark these points, on a base circle or prime circle? Because here we need to mark now follower position. See, initially follower is here, first position. This one is center of the follower, and this one is this one is base circle of the cam. So actual cam profile is here. So next position follower will be somewhere here. But follower is not stationary. Follower is moving away. During rise, it moves upward. Again, dwell it is stationary, and return again it is coming to initial position. So first 0, you can see displacement diagram. At 0, follower is at 0. But we at first position, follower is at A. At second, it is at B. 3, it is at C. So likewise, we need to mark 0, 1, 2, 3, 4, 5, 6 points on a cam profile also. And in case of a roller follower, mark these points on a prime circle, not on base circle. So mark these points on a prime circle. You can see how it is. So mark these points now. Likewise, see, we need to transfer the distances. So 0 to 1. So on the first line, you have to mark that distance 1 to A. Then you now see here 1 to 12 are marked where? You can check it again. So 1, 2, 3, 4, 5, 6. After 12, again it is 6, and 6 to 12. These points are marked on prime circle, not on base circle. Remember this thing. The roller centers are on a prime circle because these are nothing but trace points. 1 to 6 and 6 to 12 are trace points. The points which are used to draw the curve are called the trace points. Okay. Now what is next step here? Mark A, B, C, D. So 1A as distance, mark arc on this. 2B as distance, mark arc, and so on. We'll get A, B, C, D, E, F up to L on a cam profile. So just see how we are marking it. So 1A at the distance, you can mark here, it is 1A. So this is your A point. Next, 2B as a distance from displacement diagram. We are transferring distances from displacement diagram. 2B, mark on this cam. So it is your 2B point. then 3C, 32C. You can mark with compass also. You need to take always scale, because scale, when you're trying to draw with scale, it is time consuming. You can take directly distance in compass and mark the distance on a cam profile. I'm not saying cam profile, but on a cam drawing. To transfer these distances, A, B, C, D, E, F, like this. This 5 to E, then 6 to F, and after 12 the distance remains same, so no need to change the distance. You can directly draw arc also. 6 to F. Similarly, you can transfer the distances, that is 7G, 8H, 9I, and so on. So do this. If any doubt in between, you can ask me. And see, the last point must be where? On the base circle or prime circle? That is 12 point on a prime circle. So 0 and 12 are on prime circle. This is your roller circle. Its center is here. Now join this point by smooth curve. So give what will be name of these points? It will be A, B, C, D up to K and L. Now see, okay, sorry, it is roller follower. Remember, in case of roller follower, if it is knife edge follower, we can join that point directly. But the follower given is roller follower. Hence, here by this point as center, we have to draw rollers at each point. Means A point as center here, draw roller. B point as center, draw roller. Likewise, draw rollers at every point drawn. इतने समझ लेगा? Hello, this cam profile how I am drawing, is it clear? Just we have to draw rollers here. Draw rollers through each point, and you can see the last roller. Last roller must touches with base circle. You can see this, very important. This first roller and last roller means start rises here at 0 position and ends at 0 position. This is your cam, actual cam, and this is your cam curve when I draw tangent to these rollers. So you can see the first roller and last roller must touches the base circle, and you can come to know that if your drawing is such that means if your last roller is touching base circle, means whatever your drawing is right. And after this, you have to draw a smooth curve which will be tangent to these rollers. Yes, you can see this curve is tangent to the base of the rollers. Means you have to draw a curve which is tangent to these circles, roller circles. And you can see here also, this one is stationary period, dual period. So this circle is base circle, the outer circle is prime circle. The curve we drawn is called as a cam curve, red color curve. The curve which is passing through center of the rollers is called as a pitch curve. Keep in mind, this terminology is very important. The circle, base circle, around it prime circle. Curve which is tangent to roller circle is called as a cam profile or a cam curve. Curve passing through center of the rollers is called as a pitch curve. This one is roller follower. The terms are clear? Hello? These terms are clear? अरे समझते क्या नहीं? Base circle, prime circle, pitch curve and cam curve. 4 terms only. Is it clear or not?
Yes, yes.
Yes, sir.
Yes.
Okay. So the procedure is clear also. Any doubt here in between?
No.
Okay, so draw it. I'll give 5 minutes to all. You draw it, then I will start next numerical. Complete this and share me. I will continue next lecture also because TM lecture is not there now. All of you complete this numerical. If any doubt, I will be online. Don't leave the lectures. Important numerical, just we discuss. How to draw a cam profile when the follower is roller follower. It is radial and the motion is uniform motion. So complete this first, then we'll go for next.